Hey guys, this video is to help you guys practice your Z intervals. We have an upcoming test, and so in this video, we're going to we're going to practice, not learn, we're going to practice writing a Z interval with and without data. So let's get started. Okay, so let's talk about the basics before we get started on how to write a confidence interval. There are 4 parts to writing a confidence interval. The first part is called state, and you have to state what the problem's about. And in this section, we're going to state the parameter and the purpose. So in this chapter, we focused on units and not proportions. So the parameter here is going to be mu. And mu is the true, mean, whatever. Cost of lunch, the true mean weight of a baby. Okay? And the purpose of this is we don't know the parameter, so we're going to use x bar to estimate mu. So that's what we're planning to do here. Okay. When you plan out the problem, you want to make sure that all the conditions work. The conditions are that it's a simple random sample, that the distribution is approximately normal, and that the samples can be considered independent. So this one's pretty straightforward, but this one, approximately normal, first, if you're given data, you have to graph. And you have to see, is it approximately normal? So when you graph, you can graph a stem plot, you can graph a histogram, or you can graph a dot plot. You're not always going to be given data. Suppose you weren't given data. Well, how are you going to figure out if it's approximately normal when you can't see it? Well, we have the central limit theorem to help us with that. That says that if the sample size is large enough, which we consider to be 30, then the sampling distribution is approximately normal. Okay, and independent means that the population is at least 10 times the sample. All right. When we're ready to do the problem, you have to have these 3 parts. You have to write down the formula, you have to substitute in all your statistics, and you have to actually do the problem. So the statistic here is going to be x bar for units, the critical value is z, and the standard deviation of the statistic is sigma over root n. And when you're ready to conclude, you would say, I am 95, I am 90%, whatever, confident that the true mean cost of lunch is $5. Okay? All right, so here's an example. In this example, we have a growing concern of employers is time spent in activities like surfing the web and emailing friends during work. Suppose the CEO of a large company wants to determine whether the average amount of wasted time during an 8-hour day is less than, so here it looks that's our claim, then 120 minutes, sounds like that's our parameter. Each person in the random sample of 10, sounds like that's our sample size, was contacted, and this is how much time they spent on the computer doing personal stuff. Estimate the true time employees spent surfing the web with this assumption of sigma is 9.45. Okay, so we have data in this one, so in the back of my mind I have to think I have to graph during the planned portion. Okay, so when we get to the planned portion, don't forget we have to graph. Okay, so the state portion is pretty easy. What I'd like you to do now is pause the video and try to do this problem on your own, and then turn the video back on and see if you did it correctly. Okay, so like we said in the first slide, we're going to state the parameter, and the parameter here is the true mean time spent surfing the web. And x bar is used to estimate mu. All right, so that's the first part of our confidence interval. The second part of our confidence interval is the plan portion. So when we plan this out, we want to check these 3 things. Was the data collected at random? Is the distribution approximately normal? And were the samples considered to be independent? Okay. I actually saw in the last test people wrote this and then would cross them out when they were done, and I thought that was an excellent way to hit all conditions. So good job for those of you that did that. Okay, so for the plan portion, rather than go back, I'll just tell you that it did say that the employees were chosen at random. Okay, And now so we're done with that. Now we have to check, is the distribution approximately normal? So what you're going to want to do is you're going to put all your data into a list. I've already done that, so go ahead and pause and do that yourself. Okay, and you have to decide how you want to graph this. We said stem plot, dot plot, or histogram. I don't think a dot plot would be appropriate here, so I'm going to show you both a stem plot and a histogram, and you can choose either one of those. So here is the data that was given in the very first slide. So I'm going to go ahead and sort that so I can do a stem plot. So I'm going to go to Stat, Sort A, and Sort List 1. Okay, so now it's all in numerical order, so I can look at it. And so if you choose to do a stem plot, we have our stems. We have 1, 0, 1, 1, 1, 2, 1, 3. And then using the calculator, I can fill in the rest. We have 100, 105, 112, 111, 12, 13, 13, 17, 19, 8, and 1. And don't forget your key. So we'll say 1-0 is 100 minutes. Okay? All right, another graph you can do, we said, was a histogram. So you could draw this, or you can draw a histogram. All right, so to draw the histogram, it takes a little bit more work. So let's use our calculator again to help us out. So I'm going to go ahead and set up my graphing menu, which is second y equals. And mine's already ready to go. And so make sure yours looks like mine. And when you're ready, you're going to go to zoom 9. Ooh, looks skewed right, okay? But let's just check that window to be, let's push trace first. And you can see that the calculator is counting. The first bar is 100 to 107.75. And nobody counts by that random decimal of a number. So we're going to fix that in our window. All right, so our minimum value is 100. And we're going to change that scale, and you can change it to either 7 or 8. So I'm going to try 8. Oops, I don't want to do that. Sorry, 100. Change the scale to 8. And then you're going to push graph, not zoom 9, graph. All right, so kind of you can see the shape here. I'm going to go back and change the window, see if 7 looks any different. So I changed it to 7. We still have the same shape. So we'll go with the scaling of 7. So we'll do that. It doesn't matter if you chose 8 because they both are skewed right. Okay, so now that I have this, I'm going to push trace. I'm not starting at the origin, so put that little like skip line. And so the first bar is our frequency. Our first bar goes from 100 to 107, and it's 2 units tall. The next bar goes from 107 to 114, and it's 4 units tall. The next bar goes from 114 to 121, and it's 2 units tall. Okay, then we have a gap from 121 to 128, and the last bar is 128 to 135, and that is 2 units tall. Okay, so there's a histogram. You can choose either one of those. Regardless of whichever one you chose, those are both skewed right. So we're going to say let's say distributions appear skewed right. Assume approximately normal, and that's me proceeding with caution. Proceed with caution. Okay, and let's see, we did a sample size of 10, right? 2, 4, that's 6, 7, 8, 9, yeah, 10 times 10 is 100 employees, and it said that it was a large firm in the very first sentence, so the population is at least 10 times the sample. All right, so since all of this works, let's use a z interval. Let's get started. Okay, so now we're done with the state and the plan. Let's do the problem. All right, so to do the problem, we said that the formula is x bar plus or minus z times sigma over root n. To get those numbers, we can use the calculator. So stat test, and we're going to go with the z interval, and that is number 7. And we have data this time. The standard deviation was 9.45. That has to be given to you in order to do the problem. We're going to use list 1, and it didn't say a confidence level, so I'm going to go ahead and go with 95. And when I do that, I get 114.9 plus or minus, I just happen to know that's 1.96 times 9.45 over the square root of 10. And that comes out to 109.04 to 120.76. I am 95% confident that the true mean time spent surfing the web is between 109.04 minutes and 120.76 minutes. Okay, so that's how you write a confidence interval using data. Now, let's say that we're not going to use data. Let's say that you're going to be given statistics, so like in this example. Suppose we had the same example, but in this example, I didn't give you data, I just said that's the mean. The only thing that would change is the plan portion, okay? Everything else would stay the same, okay? So let's double check our plan. There's 3 things, right? SRS, approximately normal, and independent. All right, so it still was an SRS, so just to save time, I'm not going to write it out. It's still independent. Okay, let's check approximately normal. There were 10 people we interviewed. That's less than 30. The central limit theorem does not apply here. So in this situation, if I didn't have data, I would have to say, assume the distribution is approximately normal and proceed with caution. So if you're not given data, try to use the central limit theorem, and if you can't use the central limit theorem, just continue to proceed with caution. All right, guys, I hope that helped. Good luck studying for the test, and good luck with Z intervals. Have a great night.